Hello, everyone, and welcome to Writing a SQL Select Join. Okay, now we have our database pretty much designed, pretty much built, physically built, with all the relationships and everything associated with it. Good job. If you understand what you're doing up to this point, you're doing great. If you understand a little bit, you're also doing pretty well. We're going to practice this quite a few times throughout the rest of the semester. Based upon where you are in the scale of things, hopefully you're starting to get this stuff a little bit. However, I also believe this video should help you understand a few more things in relation to what it is we're actually doing. I find that many students are still confused as to what are we doing and why. And that's understandable because you haven't really seen how it actually comes together. And with that, you're going to see it more come together when you get in subsequent classes, basically programming 2, where we start putting the database with your programming languages and actually build a application, a database application. But until then, hopefully what you'll see now, starting right now, is it coming together based upon some selects, based upon getting the information out. At this point, for the most part, everything that we have done is talking about storage, storing our data as efficiently and as effectively as possible so we be scalable and we can get the information out as quickly as we possibly can. That's our goal, get it out very quickly. As you know, in several of your web applications you may be using, you want that information back quickly, not slowly. We have no patience anymore for slow retrieval of data, do we? All right, so this particular video is going to walk in the introduction of SQL joins. Now, joins can get, I don't want to say complicated, but they get very involved, and we're going to be practicing them once again over the rest of this course. But right now, we want to introduce them to you, and our hope is that by introducing them to you, we can show you a little bit of what we mean by getting the information out and how all this breaking apart and all these many tables actually brings it all back together again to provide useful information. All right, so let's kind of talk about this. And I'm kind of repeating myself here. I tend to do that, I think. So why the need to join tables? Well, through the process of database design and normalization, and we're going to cover normalization here in the next few weeks, we have formed tables that are related to each other that allows for scalability and elimination of redundancy. But all of this is related data, but all this related data is in different tables. So it really means nothing to anybody, not you and not your users who actually need the information. We need a way to bridge all of it back together again or bring it all back together again to provide good information. I always, in my classes, have a distinction upon data and information. Data is what's stored. It means nothing. It's raw. If anybody looks at it, you really can't tell, for the most part, heads or tails, what it's really telling you. Information is that data that's processed. And with that, it provides information for somebody to do something with. And that's what we do as IT professionals for the most part, especially software developers. We're processing data one way or the other and presenting it in a way that makes sense to somebody so they can make decisions or have the information they need to move forward. Does that make sense? Okay. To do this, we need to do what's called an SQL join. We did SQL selects already a little last week, and we showed you how to do it. It was mostly against one table. That's fine, but in relational databases, that's usually not what happens. We usually got to join our tables back together again because we broke them all apart. So our small introduction to SQL, or SQL selects, I should say, was good, and hopefully you got it, and you got a little bit out of it, but now we got to bump it up a step. All right. So an SQL join clause is used to combine records from two or more tables in a database. The join is a means for combining fields from two tables by using values common to each. Okay. And again, we are joining two tables. We can actually join 3 tables, 4 tables, 5 tables, whatever is needed based upon what is being asked of us and how the database is set up. What's one of these things look like? Well, here's one right here, okay? And we're going to get into SQL Server here in a few minutes to kind of show you and demonstrate and actually run it for you. So I think hopefully that might help a little bit more. But for the most part, what we're doing, if we look at our instructors and courses that we've been following throughout the semester, for every instructor, they can teach many courses. So if we wanted that, if somebody came to us, or maybe I want that, I want to know what I'm teaching this semester. And with that said, or maybe my dean comes to me and says, hey, Bob, I need to know what every teacher in your division is teaching, or your department is teaching, or has taught over the years. I need to know where to go get that information. In this simple little database, I have instructors and I have courses. And as we all know by now, the courses dictates who taught the class and when they taught the class. The instructors holds the name. So he wants a list of all the instructors and he wants a list of every course they taught. Well, to do that, I need to join those tables together again. And of course, what we're going to do is join them based upon how we formed the relationship, which was based on the primary key and the foreign key. So with that said, I'll go ahead and say I want to get the instructor ID, if I want that or not, the first name, last name, course number, and the start date of the particular field, okay? Or, I'm sorry, particular tables, all right? And we're going to do that from, and we're going to tell it what tables all this data resides in. And it's going to reside in instructors and courses, okay? So 2 tables there. And then in our where clause, we're going to tell it how was it related. You got to remember, SQL knows nothing. So you got to tell it everything. Even though we did all this work in the DBMS in regards to forming referential integrity and telling the database what the foreign key is and what the primary key is and all that stuff, SQL knows none of that. You got to tell it. So in this case, we have these 2 particular tables, and they are related based upon the primary key in the instructor table and the foreign key in the course table. And when we do that, it will actually bridge it all back together again, and it will work. Okay? Let's go ahead and get out of this right here and get back into the actual database. Okay? So with that said, we're back into this again. And if I want to go ahead and run this, and if you see what I'm doing here, once again, instructor first name, last name, course number, the start date, the T instructors, the T courses, and it's going to be based upon the primary key equaling the foreign key. I'm going to go ahead and rerun this entire script just to make sure everything is working well. I'm going to have to go ahead and connect again. There you go. Everything did work. I'm going to go ahead and do a Control R here, and then just come down to that particular join statement, and we'll just run that so you can see the results of that versus trying to find it. And so what basically happened here was, as you see, Ray Harmon is teaching .NET Programming and .NET Programming 2, and here's all the courses, and then Jim Smith is doing math, and I'm doing database design in SQL. All that information, if you recall, is based upon the instructors and based upon the courses. And as you can see, those are split apart now. The only thing that puts them together is that foreign key that we established in the courses table against the primary key. And my join now puts it all back together again. That now provides information. I could give this list to my dean, and he could say, I see what's Ray teaching, I see what Jim is teaching, I see what Bob is teaching. That is now information, okay? And that's what we're trying to accomplish here. Does that make sense? All right, cool. Let's keep going on here a little bit. And let's see, I'm going to get back into my, I'll get back into this a little bit. And I'm going to talk about how do you write a join? What's the steps to writing the perfect join? I don't know if it's perfect or not, but this is how I kind of tell people how to go about this. The first thing you need to know is what are you being asked to do? So now that you're writing join statements, usually it's somebody asking you to get information out of the database. With that, those are requirements, okay? You need to truly understand and maybe ask some questions again of who's asking you for this information and what it is they're truly trying to get out of the database, all right? So you need to understand that. Once you understand that, you need to know where the data resides. So you might need to go look at the database and analyze the database to determine where is the data. Now, if you create the database, you probably have a pretty good understanding. However, most of you are going to be walking into situations where the database already exists. And if that's the case, You might need to analyze the database a little bit more and talk to maybe your DBA or other programmers around who understand the database and ask them where some of this data might exist. Once you figure out where the data exists in the different tables, then your job is to figure out how do we link them all together. In some cases, it'll be very obvious. Your foreign key and primary key. In some cases, you might have to go through another table to get to the data, if that makes sense. And you'll practice that within this class, okay? So based upon all that, then you go ahead and build your join. So you really need to know, number one, once again, I'm going to repeat myself because this is important, what it is that's being asked of you. What is the outcome? What is the output people want out of this SQL join statement? Analyzing the database to figure out where that data exists, determining then how to get that data based upon the relationships of all the tables, and then go ahead and building your join accordingly. Just a word of caution, sometimes things don't work the first time. This is not a time to get frustrated. Sometimes things won't come back the way you thought they might come back. Playing around with SQL statements to get what you're actually going after is a common routine. So if you get it done the first time, congratulations. But it is a work in progress. It's a work of art, once again, to sit back and get this to work correctly. And when you start getting to more complex databases, or I should say more involved databases with more tables, the first time you write something might not be the first time it ever really works the way you want to. So you might have to try some new things. That's all right. Don't get frustrated. Understand that's part of this job and part of doing this well. And of course, everything you do, you'll keep learning from and you'll get better at it as you go. A couple of things I want to introduce. If you step back, I'm going to go back out here again. And as you can see, I'm going to go ahead and do a Control R on this and get back down here to our join statement. It's kind of wordy, isn't it? As you see, because what we have to do now when we're joining, we have to preface every field, which we didn't do last week, or every column, I should say, with the table name. There's a shortcut to this to make this a little bit easier and a little bit more readable for your people, and they're called aliases, okay? I apologize. I'm going to go back to this. I won't expand it this time, so you can actually read this. So an SQL alias are used to give a table or column in a table a temporary name, usually a shorter name. Aliases are often used to make column names more readable, and an alias only exists for the duration of the query. So basically, when the query is done, the alias is gone. That's what an alias is all about. So let's go back out and let me show you what I mean by that. So what you do to create an alias, you just tell the SQL statement a different name for it. So, I mean, I don't know. I guess we all have aliases, right? My name is Robert, but my alias is Bob. A little bit shorter, a little bit easier, a little bit more friendly than Robert. Never really liked Robert. I had a nun who used to call me Robert, but that's a whole different story you don't want to hear about. Anyway, so with this said, we would basically have it as a little bit shorter name. And very easily, we can make it TI in this case, representing table instructor. And then courses, we can make it TC. Again, make it readable, maybe space these things out and keep them all nice and even. And then what we can do, let me make that capital, there we go. Then all we need to do is go back up here and replace. Now, of course, you can pretty much plan for this and not have to replace. You can sit back and recognize, once you get good at this, that I'm not going to write all this out and it should all work out. And so let's see, my last TI is right here. And then we'll put some TCs in here. Again, just a little something else to get used to. It's not overly important. If it's becoming a little bit overwhelming, don't worry about aliases right now. Write the whole thing out. Who cares? All right. But eventually, I want you to get used to aliases because it does help you read the thing a little bit better. And as you can see, a little bit less busy, a little bit easier to read, and we can actually figure out how to do what's really going on by more of a glance than really trying to dive into the details. Make sense? So an alias, to add an alias, all you do is give it the alias name in the from clause. There you go. All right. So if we run this again, everything's going to still run, hopefully run fine. There you go. I always worry about these videos. Things are going to run the way I want them to. If I wanted to sit back and say, I don't know, say I want to, if you actually look at these dates right here, as I kind of make this thing up, 820, let's see, we got 2000 and then I got 2018. My dean might come back, and let's just pretend this list is 1,000 rows long, okay? And dates are all over again, all over the place, because it's showing the dates of the fall semester and the spring semester and so on. He wants this ordered in a way that makes sense to him. Basically, the latest semester first. There's a way to do this, and it's called the order by clause. Okay, order by. There you go. I'll come back to my PowerPoint, and again, you can read this if you like. The order by keyword is used to sort the result set in ascending or descending order. Remember, whatever comes back from the join statement or any select statement is called a result set. The order by keyword sorts the records in ascending order by default. To sort the records in descending order, you use the DESC keyword. Again, this is kind of a nice to know right now. Don't get overwhelmed, but once you start getting used to these joins and you want to sort the result set, and so it kind of looks a little bit better, presents better information, order by is something you're going to use, and you will use, and you'll use it quite a bit. Let's get back to here. And so how do I do it? In this case here, I can sit back and say, let's sort it by DTM start date, okay? And we can go and execute this. And what we're going to see is it's going to stay in the same order because it's going to start from the earliest date on. Usually what we want to do for dates is do descending order. So we can just put the word descending there, go ahead and execute. And now you see it's giving us the latest classes and so on. All right. We can do you can sort by name, you can sort by course, you can do anything you want to do. You can sort by anything. Usually how this works is this. If I sat back and I wanted to do the date, and then I wanted to make sure it was sorted by the order of, my professors, I can sit back and very easily say, also sort this by, let's go ahead and put my different pieces in here. TC dot, we should basically preface that because we're going to have some problems if we don't. And in this case, we're going to do TI last name. There we go. IntelliSense really makes this easy. Now, it already did this for us, so I just wanted to see how I wanted to explain a little bit how this works. The very first thing you put in your order by clause is the primary sort. So it's going to sort it by date first. The second thing you put in there is your secondary sort. You can have a third, you can have a fourth, a fifth, it can go on forever. And so, but mostly I've gotten to, maybe third type sorts where you have a primary, a secondary, and a tertiary type of sorting. But again, it's going to sort primarily first, so it'll put everything in the dates. Second, it would be all the last names and how this actually worked. Okay? And there you go. Everything would work actually perfect there. That is joining. All right. Let's do one more real fast before we end this video because I know you're probably dying to see more here. Let's see, I'm going to do Control R. And let's go back to our data again. Let's just say what we want to know is, tell me, all the students, the students want to know what classes they're in, right? So you guys come to me all the time and ask me those questions. What classes am I in? Even though you register for it. And so what we need to do is we need to, if I sat back and looked at my database, I would have to figure out what do I need to do. So I know I need students, I know I need courses. And as you know, we didn't put a foreign key that relates to each other there. That came from the student courses table. So with that, we're going to have to join all three tables together because I want the first name, last name, and the courses that you've taken. But now I got to join them all together. Okay. And to save time, I already did this for you. And so in this case here, look what we did. I got the first name of the student, the last name of the student, the course name, the course number, and the start date. We got students, courses, and student courses. In this case, though, I got to join all three tables. So with that said, I will have a couple of equal statements in here. Really how it kind of works is based upon the amount of tables you're joining, your equal statements in your where clause is going to be the number of tables minus one always. So in this case, I'm joining the course table to the student's course table by the course ID. And there it is, you got to put that in there. Student ID from the students table to once again, the student course table there. And that will join it all together. Let's see what our results are. And we execute that. There you go. And see here we have James Jones is taking .NET Programming 1. James Jones is taking this, and so on. What do you think? We just joined 3 tables together. So this is kind of what we want you to kind of focus on for your assignments as you get used to this. Nothing too fancy. The final thing I want to do here, though, because it kind of drives me crazy, would be James Jones is here, James Jones is there. Boy, wouldn't it be nice if James Jones was all together so we can figure out what James Jones is doing. All right. And as you see, James Jones not only took classes in the fall, he's also taking classes in the spring. So we need to order this. So once again, ORDER, order by, and we're going to go ahead and do this as the student, and we'll just do by last name to keep this simple. There you go. So James Jones, we're going to sort it by his last name. And then what I'm going to do, I'm going to sort it by start date. So DTM, start date, and oops, sorry about that, and descending. There you go. And now when I rerun this, we see that everything's sorted together. There's Jose, there's James, and there's Sally. We ordered it by last name, so Hernandez is first, Jones is second, Smith is third. But if we come down here, we can see that Jose's classes he's taking in the spring is before the classes he's taking in the fall. All right. Makes sense? So let me do a Control R here so you can actually see this one more time. This particular with problems that we just did are available to you. They'll be on your week content under for this particular week. Go find the sample data for this, and you can actually look at this, run it yourself, see how it works, play with it, and then utilize it to write your assignments and get used to what we're doing here. All right? So that's it for this week. Now, think about what you've done. Designed the database, created the database, formed all the relationships, formed referential integrity, and now start bringing all these tables back together again. Whew. If you can do that and you're doing well, we have done a good job, and you have done a remarkable job. All right, take care.